Okay, we got a car parked on this cliff. Shh. We got a car parked on this cliff overlooking the ocean. Sounds very romantic. Makes an angle of 24 degrees. Well, you know, hey, physics and romance go hand in hand, okay? We'll talk about that later. But for right now, so the angle is 24 degrees below the horizontal. So look, they're talking about this, below the horizontal. So if you go doot, 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 if you draw the horizontal in right here, this angle right here is 24 degrees. That's what they're telling you. But I'm going to put it down here because that's where we're going to need it. Okay, so we're going to erase this. The 24 degrees, it's the angle of this hill. So I'm going to draw in dot, 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 24 degrees right there. Now, the first part of the problem is one-dimensional. It's actually not even chapter 3. It's last chapter. It's one-dimensional motion. The car goes down this hill, right? It's moving in a straight line path. Does that make sense? So the first thing we got to do is figure out what's the velocity of the car when it reaches the bottom of the hill down here, because that's going to be the starting velocity for the projectile motion part. So how do we find this velocity when the car reaches the bottom of the hill? Well, here's the info we're given. The starting velocity at the top of the hill is 0. The acceleration down the hill is 4 meters per second squared, and then the displacement, or the distance traveled, is 50 meters. So what kinematic fits this data? V, we're short on time, so I'm just going to tell you. Vf squared equals V initial squared plus 2ax. V initial at the top is 0. So now we can solve for V final. So this is going to be square root 2ax. 2 times 4 times 50. So this ends up being 20 meters per second. So we now have this velocity as the car begins projectile motion. Okay? Now, is that 20 meters per second, is the 20 meters per second perfectly x? Nope. Is the 20 meters per second perfectly y? Nope. So before you do anything else, what do we have to do to this 20 meters per second? Break it into components, which are these red arrows here, these red vectors. All right, now what's the angle inside this little thing? That's 24, just alternate interior angles from geometry. All right, so solving for Vx, I'm not going to show the trig, but you're using cosine here. That's going to be 18.27. And then Vy initial, which you have to make it negative. Your calculator is not going to tell you, but you have to make it negative. Why is this negative? Down is negative, up is positive. Our sign conventions like that. Which way is the initial y velocity? Is the initial y velocity upward or downward? Downward, so you have to make it negative. Your calculator is not going to tell you that. So that's negative 8.13. Negative because it's down. Okay, so now here's the problem. The problem is, we go back to back. The problem is, so we have water down here. Ooh. You know, if that were if you were on a date here, you'd be bummed. Like, you know, you're sitting up here, it's all romantic, looking at the sunset. Oh no, down the hill, into the water. You're never going on a date again. Okay. Okay, so the height of the cliff is 30 meters. That's our vertical displacement. So that's y equals what? 30. Negative 30. Why negative? It's going down 30 meters, right? Okay, and then the horizontal displacement is x. That's what we're looking for. Okay, now look, this question here says A, find the car's position relative to the base of the cliff. That's x, right? A wants this horizontal displacement. B wants the time in the air. You guys want to know what? You want to know something? You got to do B before A. Like, dude, how many of you noticed that? You have to do B. I mean, I suppose it's possible to do A first, but it's much easier to find time and then find horizontal displacement. So I'm going to do part B first, then part A. Okay, so I'm going to erase the text. Everybody knows what we're solving for here? I'm going to erase this text so we can solve this. All right, so let's find time in the air first. Time in the air. The decision you got to make. Are you going to use X information to get time in the air or Y information? Because you're either going to use one or the other. You never use X and Y simultaneously. What are we going to use to get time in the air?
Y.
The Y. There's not enough info in the X. All we know about the X direction is the X velocity. That's it. Oh, and I forgot to label something here. When the car is in the air, we know the X acceleration and the Y acceleration. What's the X acceleration? 0. It never changes. The Y acceleration is gravity, negative 9.8. Okay? Now, getting time is a little bit tricky. Now look, you can solve this if you're not afraid of the quadratic equation, which I am. I'm going to be honest with you. I look at the quadratic equation and I'm like, I don't want to do that. Too much work. Okay? I always try to avoid the quadratic, but if you're not afraid of the quadratic, check this out. Y equals 1/2 g t squared plus vy initial t. If you plug into this, t is the only thing missing. So like, what's our y? Negative 30. What's our g? Negative 9.8. What's our vy initial? Negative 8.13, right? See right here, vy initial. You plug in here, you're gonna, if you do the quadratic, you're gonna get t equals a positive number and t equals a negative number. The positive number, I can tell you, it's going to be 1.78. The negative number, I don't know, but guess what?
Time can't be negative.
Time can't be negative, right? It's not going to be that one. Now, what if you want to avoid the quadratic? I'm just going to tell you how to avoid the quadratic if you're just like, I don't want to do it. Look, here's what you could do. So come down here, you can find Vy final. Like when the car hits the water, what is the Y velocity? You can solve for it using a kinematic. The one that starts with V squared equals V initial squared. Using that kinematic, you're going to get negative 25.577. So I'm not showing the work here because I only have a couple minutes. But look, you get that. Once you know Vy final, then you can go Vy final equals Vy initial plus GT, and then the only thing missing is T, right? And then you'll get 1.78. So you can always avoid the quadratic, okay? All right, so now that we know time in the air, so that was part B. Find time in the air, 1.78. So now that we know that the time in the air is 1.78, how do we find the other question, which is x, the horizontal displacement? Now this is easy. The only x equation is x equals vx times t. What's the x velocity? 18.27, right? That was our x velocity right there. And then we now know the time, 1.78 seconds. And you are in there. Boom. All right, 32.5 meters. That's the maximum horizontal range.